Urbanization and the evolution of modern cities have led to the development of high-rise building construction. But what is the real environment impact of these buildings? Traditionally designed with concrete as the main structural material, their construction implies an increase of CO2 emissions released into the atmosphere, air pollution, and a rise in energy and water consumption. These consequences call for the development of new sustainable strategies outside of the industrial comfort zone, such as the incorporation of wood as the structural element. Cross-laminated timber has emerged as a new structural strategy that Chilean architects have begun to incorporate into the country's architecture, adapted to local conditions and norms. The Tamango Project by Tallwood architects is an example of the challenges and opportunities of wooden construction in the country and the region, as it might potentially be the first dual-story building with an engineered timber structure, changing the traditional construction paradigm of the area. The mango represents a step into sustainable solutions that follow an integrated design process through all the stages of an architectural project. Tall buildings in CLT already exist around the world, demonstrating that using wood as the main structural material in high-rise buildings can be the future. Besides being a renewable source which cannot be depleted and is able to supply a continuous source of clean energy, wood provides sustainable solutions that, combined with technological advances, cover all stages of its life cycle, from its fabrication, assembly, and application. During its fabrication, each kilogram of wood captures 1.8 kg of CO2, and its assembly needs a dry construction that is silent and does not generate waste. When inhabiting the building, wood has excellent thermal and hygroscopic properties, which contribute to its energy efficient and user comfort. The local conditions of Coyhaique, Chile, where the burning of damp wood for heating interiors releases a great deal of CO2 emissions, has made it one of the most contaminated cities in Latin America. In response to this, the Mango's goal was to propose innovative solutions within two main lines: to be sustainable and to develop an efficient construction system, always considering the difficult access to materials and workforce in the area. Inverting the traditional process, the Mango's design incorporates a multidisciplinary team integrated by structural engineers, fire resistance, energy efficiency, and acoustics specialists that analyzed all the possible outcomes from the beginning of the process. Simultaneously, the project developed a study of thermal envelopes with experts in energy efficiency from Chile, Finland, and Canada, aiming to create a high-rise building with sustainable strategies that helps with the decontamination of the area. Using the latest innovations for joining wood layer, mass timber products, also known as compressed layers of wood that create structural load-bearing elements, can have adjustable sizes created for panels, posts, and beams, all which enable high-strength system, much like concrete and steel, but in significantly lighter weights. The Mango's structure was developed by previously designed wood elements CLT, LVL, and glulam, together with certified sound timber with different structural degrees. According to the Engineered Wood Association, CLT prefabricated panels are composed of several pressed layers, usually 3, 5, 7 or 9, of kiln-dried lumber boards stacked in alternating directions, joined with structural adhesives. Maintaining a right angle when gluing these layers gives the panel structural rigidity in both directions. To achieve accurate prefabricated structure results, the project worked with previous building information model, where the team detailed every panel and their future assembly. Once in the construction site, these panels were rapidly and efficiently joined together, much like a puzzle. As a complement to CLT panels, the strategy incorporated laminated veneer lumber, a construction material produced by dried and graded wooden veneers that are bounded together under heat and pressure in large panels that are usually used for beams, trusses, planks and rafters. Despite the process obstacles, for example, the lack of progress in the Chilean code for high-rise timber structures with more than 5 levels, the 1,870 m3 of wooden structures captures 1,230 tons of CO2, which already surpasses the emission due to its fabrication and transportation. During the design process, it developed an energy-efficient strategy that created heating from electric pump and a thermal skin that saves 75% of the expenses in monthly heating and 60% of energy savings in contrast with equivalent housing projects. In addition, if the building's life cycle comes to an end, its structural elements are easy to disassemble and become available for reuse in future projects. As a regional pioneer, Tamango takes the first step and establishes itself as a model for future architecture projects in Latin America, where height is no longer a problem for wood structure system. Introducing CLT wood in a two-story building, it demonstrates the country's effort during the last decades and enables new opportunities for the region. Thanks for watching this video till the end, and do subscribe to the channel to get the latest update on construction videos around the world.